Hi, I'm Mr. Taylor. I'm in charge of the computing department here at MEA. There's two different courses that we offer currently. So I just wanted to make you aware of that. They're both very, very different courses. So if your child or yourself are interested in taking a course in IT, we do offer a GCSE in computer science, and then we offer a more vocational course in iMedia. They're both very different. Um, the CAMMAT in iMedia is the equivalent of a level two qualification, but it's primarily coursework based, whereas the GCSE is very theory based, exam assessed. So they are very different. So we've got to make two different PowerPoints for you to go through and listen and see what the courses are like. But just be aware that there's two different options and you can only pick one of them. So for GCSE computer science, with any GCSE computer science course at the moment, you are totally assessed on exams. So there's no coursework. Now, if you do some reading up around this, you might see that this used to happen before. You used to have a programming project that you had to do, and this year is the last year that has to be done. So your child moving into year 10 now will not have to do a separate bit of coursework, which is externally assessed after they've gone and completed it in school. They will simply have two exams, both at the end of year 11, May or June time. And the names of those exams are on the screen at the moment. We'll go through what sort of content's in each of those as we go through the PowerPoint. So we call this paper one, which is computer systems. The course is split up into a theory-based side and then a more practical, logical thinking-based side, which is paper two. So as part of paper one, you can see on the left-hand side of the screen, these are the topics that we cover. So systems architecture basically means how a computer is set up from the inside. So what components are inside, memory, storage, the processor, and how they work with each other to perform tasks. So we learn about that. And then obviously we learn about memory and storage in a bit more detail when we move on to 1.2. 1.3 and 1.4 are all about networks, the different types of networks that you might use, why you might use them, how to keep them safe in 1.4, some issues around that. 1.5 system software, that's different to any other type of software that you might have, that you might use on your laptop or your phone. System software is a software that comes with an operating system. So it's a different type of software, and we learn about that. And then more interestingly is the last point, 1.6, where we learn about how IT affects everybody's lives in a positive or a negative way, through ethics, legally, culturally, and that allows a bit more room for a discussion and kind of exploring those as a group normally. Like I say, and you can see on here that the students will have a full hour and a half paper in the summer of year 11 where they're not allowed to use a calculator, and it's mainly theory based, and you'll have lots of different types of questions, multiple choice questions, and then there will always be a couple of 6, 7, 8 mark questions, which are more like essay questions. So if that isn't your strength, answering long essay style questions, that might be a little bit of a concern, because what are marked on your spelling, punctuation, grammar, and your ability to argue a point for that. So this is about paper two. This is the other paper that they sit. It depends when we teach paper two, depending on what group we normally get, what mix of students that we have. A lot of the time, we might start out teaching this at the start of year 10, just because it's a bit of a jump from year 9. Like I said at the start of the presentation, you don't have to produce a programming bit of coursework or a programming report. I'll show you what some of those look like later on, but you don't have to actually produce any programming for that to be assessed. We will learn how to program in at least one programming language, though. We have to be able to do that, because if not, you'll find, particularly 2.1 and 2.2 really, really difficult. You need to learn how to program a computer. And then in 2.1, learn about different sorts of algorithms, sorting algorithms, search algorithms, the ability to make your own algorithms. And 2.3 is about making programs that are good, that are robust, that aren't going to break. And we learn how to test programs and how to fix them and how to make them better and more efficient. Boolean logic is just things to do with logic. We learn about logic gates. We learn about rules within inside the computer and why things work and why things don't. 2.5 is, again, just exploring a programming language, but within an integrated development environment. And what that means is just a specialist program to learn and to develop a program in. Just as I'm using Microsoft PowerPoint here to make a PowerPoint, we would use an integrated development environment to make a Python program. And again, with this, the written paper is an hour and a half long. It's worth 50% of the GCSE. They do have longer answers here, but not as much essay style questions in them. Okay, so over the next couple of slides, I'm going to show you some examples of work. One of the examples is an assessed programming project, which we don't send off anymore. It gives you an idea of the sort of programming that students will do. Like I say, even though it's not assessed, students have to be able to do it to access the exam. So it just gives you a good idea of how we approach that. And then I'll show you some actual work that students have done so you can see the quality of work that we expect in computer science to get a good grade. So this is some student success criteria. What they've gone and done is they've been given a task, and the task has asked them to do program something, to do some programming, and they've had to look at that task and then decide what they actually have to do for it. It's not as simple as just make a program. They have to decide their own success criteria, which is quite a difficult skill in itself. And then they'll later use this at the end of the project to evaluate and see whether they've done a good job or not. So it's a part of the design process and a real key skill. So after the student has come up with some success criteria and they've got an idea of what they need to do to make a successful program and deliver a good product to the client, is they'll do some design work. And we teach students two different ways of doing this. So this student has gone and written some pseudocode, which looks very complicated when you look at it, and it is. So we obviously spend quite a bit of time going through and teaching that. This example here is quite complicated. The student's gone and made a function with a couple of different loops in there, and a nested if statement. So it is a very, very complicated bit of work here. Some students may choose to do this in a flowchart as well, but it's just part of the design process. So even though we've given this project to the students, a whole big design, a program and create it, like I say, this isn't sent off, but they will get questions like this in their exam at the end of year 11. So they have to be able to do something like this, come up with some success criteria for a program and do a design, whether that's a flowchart or some pseudocode. After the student's gone and done some design, so they've got an idea of how the program should be written and how it should work and how it should link with other parts of the program, they'll start to program it in the computer. Now, we always use Python at school. That's generally what other schools use as well. It's the most accessible programming language. It's free. So if you've got a device at home, what I would do is I'd advise you to maybe have a look at it. You can type in Python programming language and you can have a look at some Python code. You can quite easily find some tutorials. I would advise you and your child to have a little look through that and see whether that's the sort of thing that they would be interested in. Either pupils really, really like it and they like the idea of solving problems and getting something working, and they have that kind of mindset, or sometimes it can be quite frustrating. So I'd advise just having a little look into that. If you think your child's interested in taking computer science, do some Python tutorials. I'll put a link on this slide as well, just so you can have a go and see what you think, maybe as a family together. After students have gone and created a program, I mean, they're probably going to test it along the way just to see whether it's working. But when they think they've got a final version of that program and they've met a lot of that success criteria that they've defined at the start of the systems life cycle, they'll create their own testing table. Now, this is a very, very short one. Testing tables that our students will do will probably have about 30 to 50 tests in them. So this isn't the volume of work that you'd be completing. It'd be a lot more than that. But what they do is obviously test it, just like a professional would do. If you go and make a program, if you go and make anything, you run it through some tests to see whether it's suitable for the client. So we learn how to do that and how to get better at doing that as well. Okay, so what you've got in front of you is just some student work that's been sent to me over this current lockdown. But it's representative of what our books would look like in school and what we'd expect from a year 10 student anyway. We've got a lot of exam questions here, and we do a lot of exam practice, and the reason for that is at the end of year 11, your child's grade in computer science is determined by 3 hours worth of exam, split into two 90-minute exams, so they have to be good at it. They have to not worry about exams. They have to be confident going in there. So any topic that we learn from the topics that you can see on slides 4 and 5, any one of those topics, they're all assessed by exam. So straight away, as soon as they get into year 10, we start doing exam work, and we do a lot of homework, and it's always through exams. So I would say a factor in picking computer science is for a student to be, they're going to have to bear that in mind. Okay, so to be successful in computer science, I wanted to just pick out a little bit of the text that I've put in the options book. Surprisingly, you won't be using a computer for every single lesson. A lot of computer science at GCSE is paper-based and learning the theory behind things. So you don't necessarily need a powerful computer at home to do computer science. What you do need is to be okay with the fact that you're doing no coursework and everything's based on an exam. And you need to be okay with the fact that you're going to be given regular homework every week, and you're going to have to revise as part of that. I would say, just like I put on the other slide about looking into learning a programming language, I would say you have to be the sort of student that enjoys doing that, because a lot of this, like in paper 2, a lot of the bits that we're going to be going through are learning about algorithms and programming. And if that's not your sort of thing, you're not going to invest the time in it and enjoy it. So you have to be the sort of student that likes maths, that likes problem solving, that likes logic, and that is more how you would be successful in computer science than just enjoying computers. Okay, so after you finish a GCSE in computer science and you get a good grade, generally those sorts of students go to do A levels, or they go and study something else at college. GCSE computer science is quite a hard GCSE, and it's very, very different to iMedia. So I just want to make it clear at this point, because we do offer 2 courses. iMedia is very much learning how to use a computer, how to make graphics, how to make websites. And computer science is the theory and how things work, really learning how a computer works and the maths behind that and the science behind it. It's not as practical as iMedia. It's not as skills based. I mean, you do some programming in computer science, but it is very, very different. Although they're both 2 IT courses, they are very, very different. So typically, if you wanted to go on and do A levels and go to a college just to do A levels, and you that's where you wanted to go. Computer science would be the option for you. If you enjoy IT and you like making things on a computer and you've got an interest in websites and graphics, iMedia is where you would go. Okay, so this slide is also on the iMedia slide, because I believe that it doesn't really matter at this stage whether you want to be a hardware engineer or you want to be a multimedia developer. Picking either computer science or iMedia would be fine to any of these roles. It's more a case of what you would pick after your GCSE that would make a big difference. So all of these job roles are fine for either course. I think the deciding factor really needs to be, what would your child like to do after their GCSE? Are they going to do A-levels at a college and then move on to university? Or are they going to look for a job or an apprenticeship afterwards? Or do they really want to do something practical with multimedia, video editing, graphics editing? If it is moving on to A-levels, pick computer science. You have to have an interest in it, because if you don't have an interest in it, you won't want to put as much time in it into the course as you need to, and you won't do as well at it as you could do. If you just want to go into IT because you like IT and you like using IT, then iMedia is the option for you. And I know it's a little bit confusing, so if you just flick to the next slide. So just because it is a little bit complicated having two similar IT courses, well, they seem similar, but in fact they're not. I've gone and put the specification link there for the computer science course. It's important that you use that link and don't look at anything else, because there are different courses, and then there's even the same course but different types of that course out there. So that is the link that you want, and it goes through all of the topics that you'll cover in that course. But I've also put my email address on there, so you can email me if you've got any questions, and I'm guessing you might do, particularly about the difference between iMedia and computer science. Like I said at the start of the slide, your child can only pick one of those options, so it's important that we do pick the right one for them. So feel free to give me an email if you need to.